Hi there, guys. Just a quick video to go over these two homework questions. Remember to title your graph. These are the presidential ages at inauguration. Be sure to indicate a key. So 5 bar 4 represents 54 years old here. So remember, the ages were in the 40s and the 50s and the 60s. If we hadn't split the stems into lower 40s, upper 40s, lower 50s, upper 50s, etc., if we hadn't split the stems, we would have only had, if you will, 3 bars of data. So splitting the stems here was pretty important because it gives us a much better idea of the shape. Remember, I'm not so concerned whether or not you put the leaves in order, because whether they are in order or not, by turning the graph, we get a nice idea of what the shape of the graph looks like. It essentially turns the graph into a histogram. So this shape would be relatively bell-shaped. It's certainly a symmetric graph. So a typical president is inaugurated in an age around in the 50s somewhere, probably the mid-50s. And then the spread of the data run from a low age of 42 to a high age of 69. So that's a spread of 27 years. So take a look then at the next question. This is a back-to-back stem plot, a back-to-back stem and leaf plot of calories in hot dogs. Over here we have the poultry calories, and over here we have the meat calories. Now understand, the stems here include both the hundreds place and the tens place, so that all of the individual leaves are the ones place. And we certainly didn't want to split the stems here because we have a low calorie count of 86 and a high calorie count of 195. So we have plenty of detail here. We didn't need to split our stems. I've still labeled meat side, poultry side. These are calories in hot dogs. I still have a key, so the 14 bar 2, that's 142 calories. So I wanted you to compare the shapes, compare what's typical, and then compare the variability. Now understand, I picked these questions because I knew the shapes were not typical of what we had already seen. So for the poultry data, notice it's not really bell-shaped. It's not really bell-shaped. It's really not skewed toward either direction. What this graph illustrates are clusters. There is a lower calorie count cluster, and there's a higher calorie count cluster with this guy way over here, and then just a couple in the middle. So really, when I look at this, I see two clusters, and if you think about what these represent, hot dogs, it makes sense. There are some hot dogs that are advertised as lower calorie or, quote, healthier, and then there are the higher calorie hot dogs that actually taste better. And we see that same pattern if we look at the meat hot dogs. It's a little bit more dramatic. If we look at the meat hot dogs, there's this crazy meat hot dog down here that's only 107 calories. That can't possibly taste very good. But then notice there is a space or a gap here, and then we have a cluster of, if you will, lower calorie meat hot dogs, and then another small space here, and then a cluster of higher calorie hot dogs, meat hot dogs. So both shapes are common in that both distributions have two clusters of data. So in terms of what's typical, understand, it's difficult to really indicate what's typical. Think about this. There's a typical lower calorie hot dog for the poultry hot dogs, call that in the mid-90s. There's a typical higher calorie count poultry hot dog, maybe somewhere in the 140s. But think about this. If we actually took the average is likely to land here in the middle. And in fact, that's really not a very typical value because there are only two hot dogs at 113 and 129 calories that would have a calorie count close to the average. So it's hard to describe what's typical here. Same thing with the meat hot dogs. There is a typical lower calorie meat hot dog, maybe in the high 130s or low 140s. Then there's a higher calorie count meat hot dog, which is maybe in the 170s, 180s. But understand, again, if we took the average may actually land somewhere between these two clusters. The average really would not be a good representation of what's typical because there may be very few, if any, meat hot dogs at that calorie count. So understand, describing what's typical is difficult, but certainly we can compare what's typical because just by looking at the distribution, looking at them back to back, typically the poultry hot dogs have fewer calories, the meat hot dogs have more calories. So that's really the only observation you need to make. You don't have to be specific about what you think is typical for a poultry or for a meat hot dog. You can simply say that poultry hot dogs in general have lower calorie counts. Meat hot dogs in general have higher calorie counts. That would be a perfectly good comparison. What I think is interesting is that the variabilities are very similar. So both of these variabilities, notice for the poultry hot dogs, the low calorie is 86, the high calorie is 170. That's a distance of 84 calories. For the meat hot dogs, the low calorie count is 107 and the high is 195. So that's a difference of 88 calories. So in fact, that both distributions have two clusters of data. The poultry hot dogs tend to have lower calorie counts where the meat are higher. But what's interesting here is the variabilities are actually quite similar when you look at the difference between the low and high values. Hope this has been helpful.